Hi everybody, I'm Wessel and this is my guide to building the ultimate stereo system, episode 4, the Power Amplifier. Just as a side note, if you've got any questions or suggestions, please leave it in the comment section below and I'll try and answer them as soon as possible. On that note, the entire design for this project has now been completed, so if you want the schematics or the diagrams for any of this, please let me know in the comment section, I'll send them to you. Preamplifier is supplied by the same plus and minus 30 volt supply as seen in episode 2, and then there's a DC to DC converter that changes anything from 36 to 72 volts into plus and minus 15 volts for the op amps. The two channels are identical. Just looking at the left channel, it starts with a subtractor, and this allows the preamp to either accept differential input signals, or it can use an inverted signal or a non-inverted signal. I'll talk a bit more about that later on. The next stage is a simple gain stage, and that allows to compensate for the different SPL levels between the subs, mids and tweeters. And then the last section is a 20 Hz high pass filter. Now I've put this in because I'm not even going to try and produce any frequencies lower than 20 Hz. It's very difficult to produce frequencies that low, and in my opinion it's just a waste of energy. So instead of using energy to try and make those frequencies, I'm just filtering them out altogether. On the power supply, you can see there's bypass capacitors on a positive and negative 15 volt supply on each operational amplifier. Power amplifier is essentially an operational amplifier built from discrete components, and in particular it's set up to work as a non-inverting amplifier, and the gain is set by this resistor divided by this resistor plus 1. Simply put, it basically looks at the current on this transistor over here and the current on this transistor over here, and it tries to balance the two. So if you have an output doing something that your input's not doing, this transistor will get more current or less current, and that in turn will change the voltage over this resistor, and that in turn will change the current through these transistors, and in turn change the voltage across this resistor. The gain should always be fixed to a value much lower than what the operational amplifier as a whole can do. So in this case the gain is set to 3.2, and the operational amplifier as a whole has a gain of around 100. This extra gain is used to correct any errors that the amplifier might produce. This is called negative feedback. I've used 2 transistors here instead of 1 just because of the wattage requirement of the transistors. I've also put a diode over here and over here, which means the low current part of the amplifier has its own smoothing capacitors over there and over there, as long as bypass capacitors in parallel with them. The power section have its own capacitors. This creates a cleaner supply on the negative feedback section than what you'll get on the output stage. The last noteworthy part of this are these 3 diodes over here. The 3 diodes help with the biasing of the power output stage, and these resistors over here will stop thermal runaway once the main output transistor starts heating up. Even though these 2 resistors here are reasonably big, about 10% of the final impedance of the speaker, the output of the amplifier will still be 0 ohms because of the negative feedback. So any voltage drop across the resistors will be compensated for. The reason for inverting the 2 amplifiers is the current drawn out of the supply capacitors. If you've got the 0 volt line over here, one amplifier here, and the main supply, this is the plus and minus 30 volt supply, and the other amplifier over here, right hand channel, left hand channel, and you're feeding the speaker through here, the speaker through here. So if the 2 are in phase and you're producing positive current over here, you're producing positive current here over here at the same time, which means you're drawing lots of current out of this supply at the same time. So instead of doing that, we invert the output and we invert the input of one channel. Now you'll be drawing current out of here and you'll be drawing current out of here. This simply reduces the amount of current that the capacitors need to produce at an instance in time. This also enables the amplifier to be used in bridge mode. It simply means you can use the negative output of this amplifier on a speaker and then the positive output of this amplifier, and that will in reality make your amplifier 4 times stronger. This of course can put a lot of stress on the transistors, and I wouldn't recommend going to impedance lower than 8 ohm on this specific design. This is the schematic for the point-to-point wiring of the amplifier. It starts off with the plus and minus 30 volt supply through fuses, goes to the left hand side power amplifier and to the right hand power amplifier and to the pre-amplifier over there. The left hand channel of the pre-amplifier is wired to be 100 degrees out of phase. The right hand side is in phase, and the output of the preamplifier goes into the left hand side of the power amplifier, the output here to the right hand side of the power amplifier, and then the output goes through a relay. This is the relay that stops the popping sound on your speakers when you switch on and off. So when you plug the amplifier in, this relay is open. After about 3 seconds it will close, and when you remove the power or the main supply, this relay will drop out immediately. And then also the output of this amplifier is inverted. So we have an inverted input signal and an inverted output signal, which means the whole channel is still in phase, but the electronics inside works out of phase. The output relays here are simply controlled by the control signal. So the plus 30 volt control signal switch a LED power indicator on, and it also energizes the output relay. This is the preamplifier card. When building cards or populating cards, I like to always start with the lowest component and then use a rubber mat like this. So I insert the lowest component or the lowest profile component on the board, insert the component in the holes, and then I turn the board upside down and press it firmly against the rubber mat. This ensures that the component is flat against the card, and then I simply solder the two legs together. So that's it, components soldered onto the board, nice and neat. And now the extra pins or the longer pins can be cut off, and that's how you solder the components. So you always start from the lowest profile component on the board and then build it up to the highest components. Turn the board upside down and solder it from the other side. So at this point I've soldered in all the resistors, and the next level up would be the ICs or integrated circuits. Now instead of soldering them directly to the board, I prefer to use an IC holder or IC socket. So you solder the IC socket into the board and then you push the IC into the socket. So if the IC ever fails, you can simply plug it out and plug a new one in without doing any soldering. And in a similar way, you take the IC, turn the board upside down, push it firmly against the mat, and then simply solder it onto the board. And that's it. The first IC socket soldered in. So all the components have been soldered onto the preamplifier card now. And at this point it's best to take a 5-minute break, come back and just make sure you've put all the components in the correct place and that all the components are the right way around. You can also see the soldering left a flux residue on the back of the card. And flux is actually slightly conductive, so it's best to clean this off with acetone or flux remover and a toothbrush. I've checked the circuit to make sure everything is soldered correctly, and I've also cleaned the flux off the underside of the card, and all that remains now is simply to insert the ICs and the little dial that adjusts the preamp gain. So the dial simply pushes in. The only thing is to make sure the alignment is correct, because there's a little arrow on the dial that shows you in which direction it's pointing. So put it in, not quite there, and make sure it's got the correct range of adjustment. The ICs are very similar. Simply line up the first row, slightly bend the legs of the IC, and then push the other side in as well. Make sure it's nice and secure. Next is the power amplifier card. And the only special thing to mention here is that the tracks are really thick. And this was also made on a PC board with the thickest copper available. It's a 35 micron copper laminate, and you can actually feel the thickness of the copper. And that's because this amplifier could possibly produce up to 4 amps RMS, and you need lots of copper to be able to carry that sort of current. I'm going to assemble this board in exactly the same way as I assembled the preamplifier, with the exception of the 4 transistors that will be bolted onto the heatsink. These I'll solder on after I've bolted them onto the heatsink. So all the components have been soldered onto the power amplifier card, with the exception of the main output transistors. And I'm going to show you how to mount this card on a heatsink. So the first thing is, I'm going to use some spaces between the bottom of the enclosure and where the card's going to be, and these are 10 millimeters long, and you can see that's where that spacing comes from. Then the card will go on top like that, and the transistors will screw into the heatsink with these tapped holes. Now I've tapped these holes in exactly the same method as I've shown in episode 2, so you can always go back and have a look at that. So these are the transistors that I've chosen. They are fairly expensive, but I've chosen them because of their incredible linearity. So temperature doesn't really affect the current gain, and also the amount of current running through it doesn't really affect the current gain, and that's what makes them ideal for power amplifiers. On the transistor, you'll see there's a metal piece in the back. This metal piece is actually connected to the middle leg. And for this reason, you can't simply bolt the transistors onto the heatsink, because then effectively you'll short circuit out all the middle legs on all the transistors on that heatsink. And that's where these come in. There's Sargon washers, and they allow heat to be transferred between the transistor and the heatsink, but they block any electricity that would want to flow between them. So it's an insulator, electrical insulator, that's a good conductor of heat. So these will go in between the transistors and the heatsink. The larger transistors have a plastic insert on the hole or the mounting hole, but the smaller transistors doesn't, and that's what you use this little spacer for. So that spacer fits into the hole on the transistor, and that makes sure that your screw is also insulated from the body of the transistor. So first I'm going to just loosely tighten the transistors onto the heatsink. That's so that I can solder them before I tighten them properly, and that's to reduce the amount of force on the legs of the transistors. So you just simply put the whole assembly together, washer, transistor, spacer, and then tighten the screw onto the heatsink. Okay, and I'm only going to loosely tighten them and ensure that they remain as straight as possible. The larger transistor is going to be easier. There's no spacer. Screw directly in to the transistor, through the spacer, and into the heatsink. Again, making sure the transistor and the spacer stays nice and straight. Like that. And it's still quite loose, so you can still move the transistor around. At this point, it's a good idea just to make sure that you still have insulation between all the pins of the transistors. So I'm first going to test heatsink to heatsink. That rings through, and then to the middle pin on this transistor, that's clean. Middle pin on this one, clean. Middle pin on this one, clean. Middle pin on that one, clean. So that means the washers are doing their jobs and there's no electrical connection between the heatsink and the transistors. Now I'm going to connect the PC board onto the transistors. I'm going to slide this on. This is a bit tricky, onto the transistors. Now you can see why it was important not to tighten them completely, and then line them up with the board and push them on. Okay, so the board is pushed on now, and now I'm just going to line it with the spacers again to make sure that when I finally assemble the enclosure, the board would be the right height for the spacers. Once I'm happy with that, it looks pretty good, I can solder the transistors onto the board. Solder one leg on this side, one leg on this side, and then already it should be in place, and I can continue to solder the rest of the transistors. I can also turn the board around. That makes it easier to solder, because the solder will automatically run down onto the PC board. Now, because the power amplifiers are mono, you're going to need two of them for one amplifier. And I'm going to assemble the enclosure around them the same way I did in episode 2. So you can always just have a look at how I've done it in episode 2. Okay, the enclosure has been assembled now. You can see it's got the left power amplifier module, right power amplifier module, the preamplifier, fuses, the disconnect relay on the output to the speakers, the two inputs for the left and right audio, the terminals for power, and the terminals for the speaker going out. And now I'm going to wire it up, same method I've used in episode 3, and then it should be ready to start testing. So as you can see, the point-to-point wiring is complete now, and now it's time to start doing some testing. Now normally, as I always say, I would advise to take a small break, come back, recheck the wiring and make sure everything was done correctly. I've already done that, and now I can continue to test the rest of the system. So I've already got the plus and minus 30 volt supply connected to the amplifier, so I can just close these two fuses over there. And as you can see, the light from the LED has turned on. So this means it's been powered up. First thing I'm going to do is I'm just going to test to see if I have the correct supply. So I'm going to measure from the chassis earth. That's plus 28.65 minus 28.63. Okay, so we definitely have the correct supply. Next thing I'm going to do is just test to see if we've got the plus and minus 15 volt from the DC to DC converter. So that's 14.94 and minus 14.95, so that's perfect. The only real last test you can do, apart from connecting speakers and playing some music through it, is to make sure that the outputs of the amplifiers is 0 at the moment. So I'm looking at that one, that's 0.039, and this one is 0.046, so that's more than good enough. So this is the rack that I've built, and you can see the power supply and the 4 amplifiers in it, and also some other audio equipment that I'm not using at the moment. And I've tested all the amplifiers full range on my vintage B&Os, and they sound pretty good. I've also tested them with a low pass filter on those subwoofers below them, and they sound really good. Really happy with that. Well, thanks very much for watching. I hope you enjoyed it. Please subscribe and share, and I'll see you next time.